This view shows different components behind the TBM. Some systems are as long as 600 feet. At the front of the machine is the cutter head. Behind the cutter head is a soil transportation screw and a belt conveyor to move the soil away from the front of the machine. You can see on the right train cars that remove excavated soils. Sometimes a long conveyor or pressurized piping is used. The rail system is also used to bring in supplies and the concrete segments that form the inside structure of the tunnel. The cutter head located at the front of the machine is used to cut through and loosen soils and move them to a mixing chamber. The mixing chamber allows the excavated soil, mixed with special conditioners, to be molded into a paste that the screw conveyor can transport while maintaining pressure at the cutter head. The screw conveyor is used to move the excavated soils to the belt conveyor. The belt conveyor moves the soils to the muck supply train cars. These cars transport the soil out of the tunnel to be properly disposed. The disposal site for the soils from the SR-99 tunnel is still under consideration. Precast concrete segments line the tunnel walls and are brought to the front of the TBM on train cars. These segments are rotated into place by an erector arm in a predetermined sequence. The erector arm picks up each concrete segment from the supply train and puts the segment into place. The erector arm continues this process until each ring is complete. The ring of concrete segments is built within the TBM shield. Putting each concrete segment into place takes about 5 minutes, or about 60 minutes for a complete ring. During the ring placement, the TBM waits while continuing to maintain pressure on the soil. During construction of the tunnel, the Washington State Department of Transportation will take an active role in monitoring and responding to indications of ground movement. We will specify requirements for the contractor's monitoring activities and equipment operators. We'll also have our own inspectors on hand to review excavation and ground data and stop the TBM if needed. Extensive field work is underway to ensure the Washington State Department of Transportation and the contractor have the most current information for designing the tunnel and installing monitoring equipment. Gaskets around the edges of the concrete segments make the tunnel watertight. Bolts and dowels are used to line the segments and attach the segments to each other. The hole in the middle of each segment is grouted later if necessary. The erector arm continues to put the concrete segments into place. The final segment in the sequence is called the key segment. The erector arm pushes the key segment into place, completing it to the specified diameter. The articulation jacks control the direction of the TBM drive, adjusting the depth and alignment. The shove jacks are used to push the TBM forward and to maintain the necessary face pressure. The tail seals around the inner circumference at the rear of the TBM shield are used to keep water, grout, and other materials from entering the tunnel. While soil excavation continues, the machine can move forward to allow installation of the next row of concrete segments. Staggered joints provide added structural stability. When the segments are pushed outside of the TBM's tail shield, the space formerly occupied by the thickness of the shield is filled with grout, which is pumped in under pressure.